Now in last lecture we solve question up to subquestion 5. So today we solve question number 6. So here first we represent given function as y. So write in solution y is equals to, you write let y is equal to root of cos x plus root of cos of root x. So first we have to apply here a rule of addition. So we write here differentiate with respect to x. So we differentiate y with respect to x. So we write dy by dx, derivative of this first function plus derivative of this second function. So we use here addition rule, d by dx of root cos x plus d by dx of root of cos of root x. Now here this root of cos x is composite function, so we have to find a derivative of this root first. So derivative of root is 1 upon 2 root, so we write 1 upon 2 root into cos x. Then we have to find a derivative of this cos x, and derivative of cos x is minus sin x. Then plus we have to find a derivative of this outer root, so we write here 1 upon 2 root cos of root x. Then we have to find derivative of this inner function, that is cos. So derivative of this cos of root x is minus sin of root x into, we have to find the derivative of this root x. So into d by dx of root x. Because here three functions are given. This outer function is root function, inner function is cos function, and innermost function is again a root function. So we have to find three derivatives. So first derivative, we write derivative of this root as 1 upon 2 root. Then we have to find derivative of this cos. So we write derivative of this cos is minus sin. Then we have to find derivative of this root x, that is we write here 1 upon 2 root x. So we write this as minus sin x upon 2 root cos x. Then plus 1 upon, so we write this minus sign to this, so plus minus we write here minus, we write 1 into sine of root x as sine of root x upon 2 root cos of root x into derivative of this root x is 1 upon 2 root x. So we have to multiply this 2 with this 2, so we write here minus sin x upon 2 root cos x, here minus 1 by 4, so 2 into 2 we write 4, sin of root x upon, so we write this root x at first position, so root x into cos of root x. So this will be this is the required derivative of this function. Now see next subquestion 7, log of sec 3x plus tan 3x. That means this is again composite function, so we have to find a derivative of log. Then we have to find derivative of this bracket. So we write given function as y in solution, let y is equals to log of sec 3x plus tan 3x. So we write here differentiate with respect to x. So derivative of y is dy by dx. Now we have to find a derivative of this outer function first. So we write 1 upon, derivative of log is 1 upon sec 3x plus tan 3x into d by dx of, we have to find derivative of this bracket. So d by dx of sec 3x plus tan 3x. Now we have to apply here addition rule. So we have to find derivative of first term plus derivative of second term. So we write 1 upon sec 3x plus tan 3x into d by dx of sec 3x plus d by dx of tan 3x 1 upon sec 3x plus tan 3x as it is. Now we have to find derivative of sec 3x. So first we know the derivative of sec x. We know that d by dx of sec x. Derivative of sec x is sec x into tan x. Then we know the derivative of tan x. D by dx of tan x is sec square x. So here instead of x, value is 3x. So this is composite function. So first we have to find the derivative of outer function, that is derivative of sec x. Then we have to find the derivative of 3x. So we write here derivative of sec 3x as sec 3x into tan 3x into derivative of 3x. So 3 with variable x, so derivative of x is 1. So 3 into 1, we write derivative of 3x as 3. Then derivative of tan x is sec square x. So derivative of tan 3x is sec square 3x into derivative of 3x is 3. Now we write this as, we can take sec 3x common, 3 sec 3x common from both the terms. So we write here in numerator 3 sec 3x, sec 3x. So in bracket we write here tan 3x. Here from sec square 3x we take sec 3x common. So remaining term is plus sec 3x. We also take 3 common. So we write here in bracket tan 3x plus sec 3x upon this sec 3x plus tan 3x as it is. Now this tan 3x plus sec 3x means sec 3x plus tan x. So these two like terms are cancelled. So we get here derivative as 3 sec 3x. Now see question number 8. 1 plus sin x degree upon 1 minus sin x degree. So we have to reduce here this degree to radian form. So for that we know the concept, x degree is equals to x pi by 180 radian. So we have to convert this degree to radian form while differentiating the function. So we write given function as, let y equals to 1 plus sin x degree upon 1 minus sin x degree. So we reduce this x degree to radian form or convert to radian form. So we write 1 plus sin x pi upon 180, and here in denominator also 1 minus sin x pi upon 180. Now we have to differentiate this function. So this is of the form u by v. So we have to apply here quotient rule. So we write here differentiate with respect to x. Therefore derivative of y is dy by dx. So we have to apply here quotient rule, and we know the quotient rule. If y is equal to u by v, then its derivative is dy by dx is equal to v into du by dx minus u into dv by dx upon v square. So here in place of u 1 plus sin x pi by 180, and in place of v 1 minus sin x pi by 180. So first we apply the quotient rule. So we write denominator in place of v. So we write 1 minus sin x pi by 180 into derivative of u, that is derivative of this numerator 1 plus sin x pi by 180, then minus 1 plus sin x pi by 180 into derivative of v, that is derivative of denominator 1 minus sin x pi by 180 upon v square, that is square of denominator 1 minus sin x pi by 180 its bracket square. So if you have place right in front of this, so first we have to find derivative of 1, then we have to find derivative of sine. Now this is again composite function, because instead of x, value is x pi upon 180. So apply the composite function rule for this sine x pi upon 180. So first we write bracket as it is. Therefore dy by dx is equals to this 1 minus sine x pi by 180 as it is. Then derivative of 1 is 0, that is 0 plus derivative of sine is cos, so we write cos of x pi upon 180. We have to write here square bracket. Then we have to find derivative of this x pi upon 180. So pi upon 180 is constant and derivative of x is 1. So we write here pi upon 180 into derivative of x, that is 1. So we write pi upon 180. Square bracket complete here, minus 1 plus sine x pi upon 180 as it is, 1 plus sine x pi upon 180 as it is. Then derivative of 1 is 0, so we write 0 minus derivative of sine is cos, so we write cos of x pi upon 180. Then derivative of this x pi upon 180, so derivative of x is 1, pi upon 180 as it is, so we write pi upon 180. Upon v square. So we write square of this 1 minus sine x pi upon 180 its bracket square. Now 0 plus cos x pi upon 180 into pi upon 180. So we write this in multiplication. So we write here, therefore dy by dx is equals to, so first we write this pi upon 180, pi upon 180, then we write this into cos x pi upon 180 into 1 minus sine x pi upon 180. Then when we multiply or when we subtract from 0, we get minus cos x pi upon 180. Now these terms, when we write at first position, so minus minus get plus, so we write here plus pi upon 180 into cos of x pi upon 180 into 1 plus sine x pi upon 180 now you can take pi upon 180 cos x pi upon 180 common from both and write the denominator as it is, 1 minus sine x pi upon 180 its bracket square. So in next step we take this pi upon 180 cos x pi upon 180 common, so pi upon 180 into cos of x pi upon 180 in bracket 1 minus sine x pi upon 180 plus 1 plus sine x pi upon 180 upon 1 minus sine x pi upon 180 its bracket square. So here this sine x pi upon 180 get cancelled with this sine x pi upon 180 because sines are opposite. Now once you differentiate the function, you can write this radian form to degree form also. So we write this pi upon 180, pi upon 180 cos x degree, cos of x degree. So when we remove this bracket, so this minus sine x pi by 180 and this plus sine x pi by 180 get cancelled. So we get here 1 plus 1 2 in bracket upon So we write this as 1 minus sin x degree, its bracket square. So we write this as in multiplication. So we write here pi by 90. So when we divide this 180 by 2, we get pi by 90. So we write pi by 90 cos of x degree upon 1 minus sin x degree, its bracket square. Now see next sub question, question number 9. Cot of log x by 2 minus log of cot x by 2. So first we represent given function by y. So we write here let y is equals to cot of log x upon 2 minus log of cot x by 2. So we write here differentiate with respect to x. Now derivative of y, we write dy by dx is equals to, so we have to write a derivative of first function, that is d by dx of cot of log x upon 2 minus d by dx of log of cot x by 2. So first we differentiate this function. So inner function is log x by 2, outer function is cot x. So first we have to find a derivative of outer function. So we write a derivative of cot x. Derivative of cot x is minus cos x square. So we write here minus cos x square log x by 2 into d by dx of this log x by 2 minus derivative of log x is 1 upon x. So we write here derivative of log of cot x by 2 as 1 upon cot of x by 2 into d by dx of this cot x by 2. So this log x by 2 can be written as 1 by 2 into log x. So we write this minus cos x square as it is, minus cos x square log x by 2 into, so while differentiating log x by 2, we write 1 by 2 as constant and a derivative of log x is 1 by x. Then 1 upon cot x by 2 as it is, minus 1 upon cot x by 2. So here this is of the form cot x upon 2. So we write here cot x upon 2 into derivative of cot x is minus cos x square x. So we write here minus cos x square x and this 1 by 2 constant. So we write here 1 by 2 in bracket minus cos x square x. Because we write this 1 by 2 as constant, we have to find derivative of cot x, and derivative of cot x is minus cos x square x. So we write this as, so when we multiply this minus cos x square x with this 1 upon cot x by 2, so this minus minus get plus and this 2 get cancelled. So we write here minus minus plus cos x square x upon cot x, then this log x by 2. So we write at first position minus 1 upon 2x into cos x square log x by 2. So don't multiply these two with these two because this is in angle form. So we write here. Now this 1 upon cot x can be written as tan x. So we write here tan x into cos x square x minus 1 upon 2x, or you can write cos x square log x by 2 upon 2x. So in this way we differentiate this cot of log x by 2 minus log of cot x by 2. Now say subquestion 10, e raised to the power 2x minus e raised to the power minus 2x upon e raised to the power 2x plus e raised to the power minus 2x. So here we have to simplify this first. So we write in solution let y is equals to e raised to the power 2x minus e raised to the power minus 2x upon e raised to the power 2x plus e raised to the power minus 2x. So this can be simplified by two ways. You can write this e raised to the power minus 2x as 1 upon e raised to the power 2x, then cross multiply. So instead of that, we multiply numerator and denominator by e raised to the power 2x. So we multiply by e raised to the power 2x to numerator, and we divide by e raised to the power 2x to denominator. That means multiply and divide by e raised to the power 2x. So we write here e raised to the power 2x plus e raised to the power minus 2x. Now multiply to each term of numerator by e raised to the power 2x. So we get e raised to the power 2x. So we write here e raised to the power 2x into e raised to the power 2x, that is e raised to the power 2x its square. So we directly write e raised to the power 4x square minus. So when we multiply this, or you can add one more step here. So we write this as e raised to the power 2x into e raised to the power 2x minus e raised to the power 2x into e raised to the power minus 2x upon e raised to the power 2x into e raised to the power 2x plus e raised to the power 2x into e raised to the power minus 2x. Now here base is same, so we have to add the power. So we write e raised to the power 2x plus 2x minus e raised to the power 2x minus 2x upon e raised to the power 2x plus 2x plus e raised to the power 2x minus 2x. So here we write e raised to the power 4x. So e raised to the power 4x minus e raised to the power 0 upon e raised to the power 4x plus e raised to the power 0. So e raised to the power 0 is 1. So we write e raised to the power 4x minus 1 upon e raised to the power 4x plus 1 as y. Now we differentiate this term. So we have to apply here quotient rule. We write here u upon v. So you have to apply quotient rule here. So we write here differentiate with respect to x. Therefore derivative of y with respect to x is dy by dx. Instead of v, value is e raised to the power 4x plus 1 into derivative of u. So we have to find derivative of e raised to the power 4x minus 1 minus u into, that is e raised to the power 4x minus 1 into derivative of v, that is derivative of e raised to the power 4x plus 1 upon v square, that is square of e raised to the power 4x plus 1. So we write first bracket as it is e raised to the power 4x plus 1. Now derivative of first term minus derivative of second. So derivative of e raised to the power 4x is e raised to the power 4x into derivative of 4x is 4. This 1 is single constant, so its derivative is 0. So we write minus 0 minus in bracket e raised to the power 4x minus 1 in bracket derivative of e raised to the power 4x is e raised to the power 4x into derivative of 4x is 4, and 1 is single constant, so its derivative is 0 upon e raised to the power 4x plus 1 its bracket square. So when we subtract 0 from this, we get e raised to the power 4x into 4. Here also when we add 0 with this e raised to the power 4x into 4, we get e raised to the power 4x into 4. So that we can take common. So we write here e raised to the power 4x. So 4 we write at first position. So we take 4 e raised to the power 4x common from both the terms. So we write in first bracket e raised to the power 4x plus 1 minus in bracket e raised to the power 4x minus 1 upon this e raised to the power 4x plus 1 bracket square. So write here 4 e raised to the power 4x as it is. Now multiply by minus sign to second bracket. So we get here e raised to the power 4x plus 1 minus e raised to the power 4x minus minus get plus 1 upon e raised to the power 4x plus 1 its bracket square. So this e raised to the power 4x minus e raised to the power 4x get cancelled. So we get here 1 plus 1 2. So 2 into 4 we write 8. 8 e raised to the power 4x upon e raised to the power 4x plus 1 is bracket square. So in this way you have to differentiate the given functions.